We're Team 5 of the Lab06 session. So I'm Henrik Ng.
Wanyan Nguyen.
I'm Robert.
I'm Sprehanjay Banik.
And I'm Yixing Wei.
And this is our EC 2031 project.
So on the DD10 board, we have access to 10 switches and 10 LEDs. We want to create an API that gave a simple and a flexible way to control the functionality of our LEDs, specifically in patterns. This can be really useful for SCOMP programmers. What we wanted to do was create a peripheral that acts as a bridge between the software and the hardware. The goal was to make it easier for programmers to interact with the hardware in a more intuitive and efficient way, especially when they're testing or debugging. And to wrap it up, we're going to show a live demo in this presentation.
So what our peripheral does, our peripheral enables the programmer to easily control the following aspects through the API. The number of blinks, which is stored as count, which LEDs blink in each clock cycle, which is stored as pattern. How long each pulse of duty cycle lasts, which is stored as pulse width, and period blinking, which is stored as periods. So the programmer can control what the frequency and duty cycle are through modifying pulse width and period. So in implementations, we store these four as 4 different registers, through hex 20 to hex 23. And the video shows human time. So the video shows read and write operations to those registers on a human time scale. So in this case, it's the value is dictated by switch 0 to switch 8, and the clock edge is simulated through flipping on switch 9. And you can see the values on the hex 0 display.
So our peripherals on blinking capability does provide a lot of wide range of customizations and usage for the programmer. So a couple of examples are educational tools, smart thermostats, and interactive gaming. So for the educational tools, it will allow the student to learn hands-on learning about the different attributes, such as frequency of pulse width, through interaction with the D10 board, and for the thermostats, the customized LED blinkings will be representing the different modes along with frequency of blink to simplify the completion rate. And for the interactive game, we'll have an example shown here later.
The application we've chosen is Whac-A-Mole. So hopefully everyone's familiar with how Whac-A-Mole generally works. Next slide, please. We'll explain how our version works here. So to start with, all 10 switches must be raised. As soon as that happens, there'll be 3 quick blinks and then 1 slower blink. And that shows, oh, we're starting the game now. Right after that happens, each of the 10 LEDs will light up one by one to show a mole, and the player must flick the switch down as fast as possible. If you're too slow, they don't gain the point for that. And at the end of the round, all of the points are shown on the hex display. On the next slide, we'll play the video. So to start with, as you can see, the state of the LEDs mirror the switches in order to show which switches are up. Once they're all up, we have 3 fast blinks and 1 slow blink. Then the player flicks the switches according to whichever LED lights up. And at the end, you can see the points have been added. Here we can see that if the player is too slow, the LED will turn off eventually. And at the end of this, we'll see that getting the LED after it turns off does not yield any points. Overall, this demonstrates the ability of our LED peripheral to control both the duty cycle and the period with quick blinks at the start. It also shows our very versatile functionality, including the ability to functionally act as a timer with integrated status feedback.
Thank you.